Area and perimeter of basic and compound shapes. I won't go through all the formulas for basic shapes. They're on page 156 of the Year 11 Apps textbook. Perimeter, you'll remember, is the distance around the outside of a shape. I know it seems weird, but studies have shown you'll actually get perimeter questions correct more often if you trace the perimeter of the shape before you start. So perimeter for this shape would be 16 plus 16 plus 20 plus 20. You could of course do 2 lots of 16 plus 2 lots of 20. The distance around the outside, 40, 50, 60, 72 centimeters. It's length only, so we leave it as centimeters. Now for any area of a simple shape, you check that you have all the required lengths and that they're in the same units. For any straight-sided shape, if there's dimensions at right angles, those are going to be the dimensions you want for the area. So 10 and 20, this is a parallelogram, so the area formula is base times height. The base is 20, the height is 10, so the area is 200, and we're in centimeters squared. So every area question, I'm going to need to see the formula, substitute your values, and the answer with units squared. Sometimes we're going to have composite shapes, so you will have to find the areas of the simple shapes that make it up and add or subtract, and you might have to find unknown lengths. Pythagoras is a good option for finding unknown lengths with a triangle, but for this one, you'll see I've got 10 meters and 10 meters, and they've only given me these two lengths. Those are both 4. If you can follow along a horizontal or vertical line, this much of that is 4. We know that because we followed along 2 vertical parallel lines there. And this has to add up, that plus that have to be 10. So this must be 6. And the same logic works here. That's 6 as well. So do make sure you've got all the required lengths and that they're in the same units. Perimeter, work out where you're going to start. 1, 2, 3, 4, 5, 6 sides. And I've got 2 lots of 10, here and here, plus 2 lots of 6, plus 2 lots of 4. So we might as well make it a little bit easier, but of course you could write 10 plus 4 plus 6 plus 6 plus 4 plus 10. It'd be the same thing. 20 plus 12 plus 8, 40, and we're in meters, and it's perimeter, so its length, it just stays as meters. For the area of this shape, I've got the option of finding the large square and subtracting the small square, or the option of, say, finding this rectangle and adding them together. There are a lot of options there. There'll usually be more than one way to solve it. I'm going to say area equals. Now what you can do is just a little trick. The side of a square is S. I'm going to say capital S squared minus little s squared. So I'm cheating a little bit there. I'm combining the two formulas. You absolutely could say area of large square, area of small square, and then subtract them. So that's side length of the large square is 10, side length of the small square is 6. That's 100 minus 36. So the area is 64 meters squared. Now a triangle's area formula you're used to, that's half base times height. But that only works when you've got a pair of the base and the height at right angles. No right angle is marked in this triangle, so we can't assume that anything's a right angle. If this was a right angle, that would be easy. This would be half times the base times the height. but the base and the height have to be at right angles. There's a new formula that we use when I know 3 sides of a triangle, and it's useful if I don't know that it's a right angle or if it's not a right angled triangle. And this is Heron's formula. It looks complicated, but it's pretty easy. So, I'll just explain our formula. I'll draw ourselves another triangle. A, B and C are the 3 sides of a triangle. So here's A, B and C in our formula. And S is A plus B plus C, which is the perimeter of the triangle obviously, but divided by 2. So when we use Heron's formula, we do need to find S and then put S along with all the side lengths into this formula. So for this triangle, we write the formula for S. Because there's a formula, we always write the formula. We substitute the values. It doesn't matter which one's A and B and C because it's not right angled. So that's 6.5, 11.5 divided by 2. Oh, obviously that's 5.75, don't mind me. So that is our value for S, and I'm going to use that in this formula. You write Heron's formula. Sorry, this was my little explanation for Heron's formula up here. We write Heron's formula carefully. So it's the square root of S times S minus A times S minus B times S minus C. So that's the square root of S is 5.75 times 5.75 minus A, the first side, times 5.75 minus B, the second side, which is 3.5, times 5.75 minus 5. Now you can just type it in all like this, the square root and underneath the square root sign all of this, or you can show your next line of working. 5.75 times, because this subtraction is usually pretty easy, so 5.75 minus 3, that's 2.75, times 2.25 times 0.75, obviously. So here, that's the square root of all these numbers multiplied together. Keep it under that square root sign. If you're using a graphics calculator, you'd put a bracket around all of this. If you're using your green calculator, it will keep that all under that square root sign for you. Oops, I don't need a bracket. So the area of this triangle is 5.17, and I didn't give units, so I'd write units squared. So that's Heron's formula, and it's used when I know all 3 sides of a triangle and it's not a right angled triangle.